Today we're going to take a look at differentiating between permutations and combinations. So as you remember, a permutation is an arrangement where order does matter. So if you look at my set of permutations of the numbers 1, 2, and 3, you can see all of the different orders for those three numbers. And then we have combination where the order does not matter. So a combination of the numbers 1, 2, and 3 is simply those three numbers in any order. So there would be 6 permutations of the numbers and only one combination. I'm going to take a look at a few examples. So what we need to do now is decide whether or not order matters before we evaluate our answer. For our first example, we're choosing cubes out of a bag. So does the order in which we draw them matter, or do we end up with the same 4 no matter what? In this case, we would end up with the same 4, a set of 4, whether it's red, green, blue, purple, or purple, blue, green, red, you still have the same 4. So that makes this a combination. So we have 12, C4, which gives us 495 different possible sets for those 12 colored cubes. Next, we're looking at how many ways can we choose 2 of 8 swimmers to swim in the first heat. So does the order in which we choose the swimmers matter, or do we still have the same 2 swimmers swimming? In this case, again, we have another combination, so we have 8C2, which gives us a total of 28. Sorry for the handwriting, my stylus is completely broken now, so I have to use my finger. Next, we're looking at choosing our top 3 favorite movies. When you choose your top 3, you put them in order. Here's my first favorite, my second favorite, my third favorite. So this ends up being a permutation, and it also is the fundamental counting principle where we're choosing our top 3 movies and our top favorite books. So we have 10 movies. Order matters. We're choosing 3 of them. And 12 books, again, order matters, we're ranking them, P4. So that gives us a total of 8,553,600. I really apologize for the terrible writing. I don't know how you guys write on this with your fingers all day. And our last example, I'm choosing volunteers from both my 5th and 6th hour. The order in which my volunteers are chosen does not matter, so this is a combination. So we have 14 students in my 5th hour, and I'm choosing 4 of those for volunteers, and 10 in my 6th hour, choosing 2 of them, which gives me a total of 45,045. Now notice how much smaller this number is than the one where we had 2 permutations, because again, there's a lot fewer combinations than there are permutations. And here's your U-Try question.